Hey kids, today is going to be just a short couple of examples. This warm-up, you have 2 examples on a sheet. I'm going to do one extra one on top of that because we really, for this piece of probability, we only have mutually exclusive is what we haven't done. That's what ME stands for. I have a video at the end of this video for you to watch. And really, it's not a hard topic, but it is something that kids get confused with independence. So I found a nice video that really highlights the 2 things, what mutually exclusive, and some of you that have already done stat, I think maybe this is covered, but mutually exclusive. And then I will highlight some problems for you to start on your challenge problem set. So hopefully you've already started to write down this warm-up where again we have the combination, of combinations and probability. So I have a committee. I am choosing members from the committee. Doesn't matter the order. So if I want all seniors, right, that is the combination of 12 candidates, choose 4. But the probability of this event happening is the ways that my event can happen over my total sample space. And my total sample space is, this is 7 seniors, choose 4. My sample space is 12, choose 4. And I got a fraction that I reduced to 7/99 when I was done. I just popped this in my calculator. So can you do 2 juniors and, right? My denominator would be the same, would it not? 12 people choosing 4. But these 2 independent events would be choosing out of 5 juniors, only choose 2. Out of 7 seniors, only choose 2 as well, right? So that's the probability of my event being 2 juniors, 2 seniors. But how about the next one? 1 or more juniors. Well, instead of 2 ways, 1 or more juniors, how could that happen? Well, I could have, out of the 5 juniors, I could have only 1, which leaves me with how many seniors out of 7? Choosing 3, right? But then I also, so that's an add situation, right? I also, out of the 5 juniors, could pick 2, just like I did up in part B, and out of the 7 seniors, pick 2. Also, I could, out of the 5 juniors, pick 3, and out of the 7 juniors, pick only 1. Also, I could pick 4 juniors. Out of the 5 juniors, I could pick 4, and out of the 7 seniors, pick none. Right? So you see, there was no situation where I had no juniors, right? But I still have to divide all of this by my sample space because I'm asking for the probability. Sorry, I'm in a car, so this is hard for me to draw. If you hear any weird noises, it's the car situation. I got 92. I was dividing over my whole sample space, which is 12 people. Choose 4. Right, that's one long fraction bar. Sorry. And when I was done, I got 92 out of 99. But that's kind of annoying, right? Imagine I had a bigger committee to choose, right? I had more candidates to choose from. How many ways that I would do that? We talked about an easier ways problem. Yeah, complement, right? So 1 or more juniors is the same as eliminating the probability of no, right? I'm sorry, of all seniors. So all my probability minus the probabilities of having all seniors. So what was the probability of all seniors? Hello, that was A. Over 99, which is the same as 99 over 99 minus 7 over 99. Shocker, 92 over 99. Woot woot. Right, so this idea of using the complement sometimes can just make your, it's not that you're wrong to do it the other way, but can make your math a little quicker, a little easier, right? So I'm going to go through an example that you don't have on your paper yet. So if you want to add this one to your notes, so you have one example in your notes and then one kind of on a homework sheet, although you should be able to finish it here. So our objective is to focus again on the complement to determine the probability, and then also, and right, we're going to do some examples of that here, and to also distinguish between mutually exclusive, ME, as independent events. And that is going to be a video that I've linked at the end of this PowerPoint and also that I sent you in the email. All right, so let's suppose I have a factory where I make processing chips. 2% of them are defective because of whatever, right? Machinery, right? Error that is in manufacturing, be it machine or people error. I know 2% are going to be defective. And I have an inspector coming in, and let's suppose that inspector just chooses 4, right, chips at random. Assuming independence, what's the probability that of 4 that the inspector chooses, at least one of them is defective? And there's that word "at least." That is going to be a trigger that I could use the complement. So if I know that 2% are defective, what else do you know? 98% are not defective, right? So what about my strategy might be the the probability of defective is all my probabilities, which is 100%, minus, or 1, right, minus the probability of not being defective. So what's the probability of not being defective? They gave that to me, right? I don't have to do my combinations. They gave me, I already know the result of that. That's 98% or 0.98, right? And I'm doing that 4 times, right? Since they're independent event, the probability of all of those together would just be multiplying, right? So the probability of defective is 1 minus 0.98, eat the probability 4 times. Succinctly, I could write it like that. And when I was done with that, I got 0.078, I think. Check my math on that. I hit my calculator keystrokes right. I got 0.078, which of course would be 7.8%. Okay, pretty good. So let's go to the 2 examples that you have on your note sheet. So I have a basketball player. She consistently makes 75% of her free throws. Assume that each shot is independent. If she attempts 3 of them, what's the probability that she misses at least 1? So what should I do here? At least is my trigger that maybe I can do probability of my event that she misses at least 1 would be the 100% that she makes them all, or that she misses them all, minus the probability that she makes them all. Well, what's the probability that she makes them all? 75%. So this is going to be 0.75, right? How many times? All. How many times? 3. So 1 minus. And I got 0.578, right? Or 57.8%. How about the next one? All right, this is, right, a real situation here, right? Basketball, swell. But the factory, right? With defective parts, good. Information, surgeries. Look at this with the implant, right? They're telling me the rejection rate is 11%. The rest of the patients successfully accept the implant. So assuming independence in a random sample of 8, find the probability that at least one patient rejects. So if I have the rejection rate is 11%, what is the success rate? If you know 11% is failing or rejection, then what is true? Right? So the probability that you reject is all the probabilities minus the probability of the successful. So what are the probabilities of these 8 that I pull a successful, right? I know the success of all, but of these 8, right? It's like, I know the probability to make them all, but what about the 3 shots that she takes? So this would be equal to 1 minus, the success is 0.89, how many times? Right? 8 of them. Oh, I'm sorry, I copied down the wrong. This is 0.606. This one is 0.578. Sorry, again, I'm in a car, so I'm looking at mine. Very hard to keep things straight here. So I'm sorry about that. Of course, if you're on your calculator, you knew that was a wrong number. All right, so again, the clue here is looking for this at least situation is a trigger that maybe the complement would be faster, right? And that is different from when they would ask something like this, like up here with the basketball player, right? The probability of exactly one miss out of these 3, right? That is a different scenario, not at least. Exactly what would I do there? I would do, well, I know there's 0.75 of 3 shots, 2 times that I'm, right, would be successful, and then 0.25 of the 1 shot, right? So that was exactly, right? And I had my 2 and my 1 adding to the 3. Whereas here I had all 3, and you think of this as 3 out of 3. Okay. All right. So again, we already practiced the complement a bit. Here's some more practice with complements, and especially the percents where the probability is given to us in these 2 problems, or the 3, the one that I did and this one. So the next thing I want you to think about are your challenge problems, and here are the numbers that I think you should focus on of all your challenge problems to do. And then this is the video that I sent that mutually exclusive is not a hugely tested objective, but it is one of the objectives. So I think this video does a good job of taking you through it. All right, so I'm sorry to miss you today, but I will see you on Tuesday.